Okay, so in this little video, I'm going to talk about what you need to do. You have to do a formal report where you provide everything from the title page to the references page and everything in between. So you have to do a title page and an abstract and an introduction and procedures and data and results and concluding remarks and the references page. And here I've given you kind of a guideline, like a rubric of, if you look at 100 points um, for properly formatted APA style report for this lab, you would have the title page would be worth 5 points. So correctly formatting your title page give you 5 points. A correctly formatted abstract and having the proper information in there be worth 10. Introduction, that would include, for this lab, you have two parts that I mentioned. One is a brief discussion on the instrument itself, uh, the spectrophotometer, and the other is the concept of Beer's Law. Your procedures, which have to be written out in the correct voice and the correct tense, and then your data and results. That's the bulk of your grade, as far as percentage wise for this report. You have 10 points for the proper presentation of the data table, 20 points for the presentation of the Beer's Law curve, and 10 points for showing the sample calculations. Um, the concluding remarks, or the conclusion of the report, is 10 points, tying all that information together, and then a properly formatted APA style references page. Um, and for just real quick, if I go to Blackboard, um, to your section, the helpful resources from Mr. Lance, that's me. Um, these things have some good videos, like when you're doing your sample calculations and using the equation editor. That information might help you there. Setting up your paper correctly would also be part of that, and the citations and references part gives you at least a brief start on that. And then when we go back to your unit, well, let's see, let's go with one more thing before that. Let's go to helpful resources from others. Um, Here you have a couple of things: the Purdue Online Writing Lab, the Purdue OWL APA site. Uh, that link takes you to here, which gives you some great information on doing your in-text citations, your references pages. Um, the Also important for this lab, your tables and figures. So like your figures, like how to you have a scatter plot. How do you have to label it? That stuff is like, what caption do you put? Where do you put it? What is it? How do you format it? Stuff like that. Um, Another one is the Purdue Chemistry Lab Resources website. Here, you have, your parts of a lab report, the parts I've indicated already for you that I want. So, you do have to do an abstract, introduction, experimental methods and materials, that's procedures, results and discussion, that's like your data and results section, where you summarize your findings and show any tables or figures, and the concluding remarks, and the references page. So, also your writing in the lab report, the formal, um, like part of it is you have to write for lab report. For me, you have to do that in passive voice and past tense language. So, like right here, why do we write in passive voice? Um, it has some examples like what you do and do not write in there, and keep it in the third person. Uh, don't use any of pronouns. You know, at all. I, me, my, we, all that stuff. None of that. No people. Just leave the people out of it. It's understood by me as I read your report that this is your report. So, um, just keep it as best you can. Uh, it says that they should be mainly written in present tense, but the parts for me that you're going to be writing, um, you're going to be, if you take the time to write this out, um, the temperature was initially measured at 75 degrees Celsius. That's past tense. It was measured. So that's correct for me. Um, keep it was mounted. That's very important. I mean, that past tense, as in passive voice. Now, some other teachers or people that critique your paper might say they don't like that, but that's what I like. So, um, as part from Purdue Chemistry, this might be something just to help you make sure that you formulate that stuff, especially your procedure section. Um, do not write it like you're just giving instructions. Like there's an example. It says heat the solution until it boils. That's like you're telling somebody like what to do, not what was actually done. Do not write that. Write it as the solution was heated to boiling. The absorbance was measured using a spectrophotometer, like that. So you keep that kind of language going. Make sure of that. We talked about graphs and tables a little bit. Just the things that make it a good thing to understand is you don't want to give a graph that just looks like like a kindergartner did it with these little connecting the dots things. That's not what you're doing when you do a scatter plot. You did a linear regression and you had a best fit line and all that. So um, just some things that you should know about. But in terms of, you have to label it, you have to give it a title, all that stuff. It's very important. So tips for good graphs. There's some stuff on here. Um, Give the graph a title, like your dependent variables effect on your independent variable, which is what you did for yours. It was the absorbance versus concentration, I believe, of that. So absorbance was dependent on concentration. Um, so we talk more about that. But use these tools to that are on the helpful resources part, just to get that part, do a good job on it, um, and then your place to turn it in will be in the Unit 2 folder for lab related items, um, and then we'll take a quick look at that rubric again. Um, let's see. In the data and results section, you have to do, table 1, and notice that that's the way this is written. And then this is italicized. It's still Times New Roman 12-point font, but it's absorbance versus concentration. So that's your dependent variable, absorbance, what was graphed on the y-axis, and your concentration was your independent variable. So it's dependent versus independent, and then you can give the rest of the information. And if you know your wavelength, let's just say at 500 nanometers or something like that. I don't know what yours was. So, I mean, you might specify your analytical wavelength, whatever the average wavelength was for that over here. Now, this was not, you only needed to make the graph, you only needed those two things. So then you look at it, do I really need this information here? Do I need these columns? Not really, you don't. Your data table could just be concentration and absorbance and say the wavelength up here. So this shows the person this is based on 6 trials. Trial 1 was distilled water. So you might make a note below the table. You put note period, and then you type out maybe standard number 1 was pure distilled water, and standard number 6 was the original red dye, number 40, stock solution. If I can type, there we go. And then the first thing would be this needs to be italicized, the word note, and then it also needs to be double space, paragraph, double space. So it would kind of look like that, okay? And then after you have your table, you have to insert your figure. The way I would like for you to do that would be to, first of all, take your Excel graph that you made, right? This part, and you can pretty much probably just copy it from Excel, open up your Word document, paste it in there, just like that. And then I would probably center that up. And then, first of all, in here, inside where you've named the chart title, a lot of times I will put figure 1 period like that, and then I will take the figure 1 part and make sure it's italic. See that? And then I will not italicize this part, right? Keep it maybe straight. And then below that is where you have to label your figure, like talk about it, or tell what's in it. So you would say, figure 1 period, and then this scatter plot, and then you talk about the scatter plot, like what it does, shows the absorbance versus concentration data for the standards prepared in the lab. So you do that, and I also believe the figure 1 needs to be italicized right there. But you need to tell the reader what that graph says. You need to be able to explain in words, in a sentence or two, not the bunch of words, but in a sentence or two right here, this scatter plot, and then tell what it is. It shows, in this case, as concentration of the red dye solution increases, the absorbance at this particular wavelength increases. So you might also tell them what that wavelength was for that measurement, 500 nanometers. But that's very important. And also, when you're writing up your other parts of your, you're discussing your results and you're doing your conclusions or whatever, you can refer to figure 1 or refer to table 1 in the text of the paper. So, but that'll just give you, a place to, put that. Another thing is, do not break a table apart on 2 pages. Make it where it fits on 1 page. Okay, so don't have a table at the end of your bottom of your paper. Have your table, and then it falls over to the other part. And then when you're writing your concluding remarks and stuff like that, I gave you a start on that. This will just be changed a little bit, where you can you'll be able to discuss that part. Because now you've already done the Beers Law, so you don't have to say it will be calculated in your formal report, because it should have already been calculated. Then after your data, or after your figures in there, you've got your data table. You'll want to give some more data. Maybe the absorbance value for the unknown solution. So you would provide that value, and then you would take that. Looks like I spaced too many times. And then you might, on the next part, you need to have some sample calculations. So in that, you'll need to do one for the concentration. You don't have to do all 4. Like in your lab notebook, you did all your calculations. But you need to do one for the concentration of standards. And then you need to do one for the concentration of the unknown. So that's where you'd use your equation, your absorbance part, equal in the slope, which, for yours, I don't know what your slope will be. Um, but that was I think that was mine. Yeah, 3738 rather. Gotta watch out for typos. And then I would show the calculation for getting the concentration of the unknown, and I would report the concentration of the unknown. Sample calculations is a little subheading, so it would be bold like that. But show your work for one of the standard preparations, and then also for the concentration of the unknown using your linear regression formula that come from your graph. The r squared equals 1 part is not part of the equation at all. So the only part you have to use for calculation is the actual slope-intercept form of the equation. In the form, y equals mx plus b, which the b is 0. So you have to do that and make your concluding remarks after all that's done. So I want to see all of that work in a complete report. So you can show me that you followed the instructions from this video, from your all the resources that you have on Blackboard. You have the helpful resources from me and the helpful resources from the other places, like Purdue OWL and the Chem site for Purdue University, things like that. And make sure that you put that together, and you should have a dynamite report if you follow all those instructions. And just keep in mind, this is something that that most students have to do on a weekly basis. It's just a normal thing, and it takes a while to get good at it and used to it. But once you get in the habit of it, it's just like anything else, and you should be able to pull off a good lab report in no time at all.